Hello.
Hi, Michael and Martin.
Hi.
Hi. I think you guys all are in the wrong agenda. You logged in for the 30th, but it's the 23rd.
Yeah, I opened a new pull request.
Okay, I'll nudge in a second.
Declined.
Yeah.
Okay.
I think Camille was actually there before me, and I just looked at which agenda had the most recent activity and then added myself to it, but
It's the typical lemming problem, right?
yep.
Okay. Check, I'm just merging them through. And resolve conflict.
Hey, everyone.
Hi.
Okay, just fixing that. Oh, Shane, you also logged in, right? I think I
Yes.
dropped your name. I'll quickly fix it. Yeah, I'm gonna fix it in a minute. This one.
Oh, did I do the wrong day? Should...
Yeah, I think we both did.
Yeah, so okay. So this is, yeah, I think you did the wrong.
Oh, out of here.
At least you're already signed up for the next one.
Yeah, I mean,
Yeah, I'll just keep my name on there.
Yeah.
No need to remove it.
Troy, can you also add yourself to the agenda? I'll send you the link in a second.
Hi there.
Hi.
hi, Camille.
We weren't expecting you till next week.
Yeah, I added a second PR to remove myself from there.
Yep.
Confusion.
It's one of those few cases when we actually have 5 meetups in one
Yes. But I mean, we skipped one, right? So it's all good.
Yep.
You know what's really interesting?
Yes.
That the February was the first one this year with 5.
Okay.
How did that happen?
Yeah, it's the
Interesting.
first 8, 15, 22nd, 29th.
Ah. Oh, of course, there was a 29. But yeah.
What are the odds?
Okay,
Well,
I think
1 in 4 about about that. Not quite.
just refresh that. Okay, I think yeah, Troy, you need to also add you to the agenda, so we
I'm
can.
in progress.
Okay. Okay, let's get started. Just okay. So let me remind you that by being here, we all agree to the GraphQL membership agreement and to the GraphQL code of conduct. And with that, we can get started. Maybe we do a quick round of introductions first in the order of the attendee list. So I'm Michael, and I'm your host today.
Hey, it's Derek from Apollo.
Pascal from Chili Cream.
Camille from the guild, I guess.
Martin from Apollo.
Good. Shane from Apollo.
Troy from Zalando.
Awesome. Now we have 2 points on the agenda for today. 3. Oh my gosh. Okay, let's go ahead and start with the review of the field selection. And then we go through in the order.
I'm opening it up right now. Give me a sec. Do not disturb. Seems like I already have 5 minutes until I share my screen. All the time's gone. There we go. Do you see my screen?
Yep, we see
Yes.
the composite schema spec.
Yeah.
It's very good. So I made an appendix to this. The newest version is not yet published, but I will do that today. I'm currently working on the appendix for the field selection scaler. Now, one thing which changed from the last time, from the current version, is that the path now actually only is specified as a path. That's because the pipe for the composition of 2 paths does not belong into the actual path definition. This is actually somewhere in here. You see that there is a possibility to now select a selected value and then pipe it together. This could either be a path or it could be a selected object value. That's what we discussed at the end of the last session. Basically, that you can do this or this, and you can also do this for the one-off input union, or when you go nested, it's more like this, right? Exactly. So these are the changes from the last time. Now, I've also added the possibility to actually define a path and then have a selected object value, because that means that we now can do these things that we also discussed in the end of last meeting, where we basically have an array and or a list, and we want to spread this list into another list. This basically changed.
In this case, the field name coordinates is optional, right? Because by default we use the normal field name, so it could just be coordinates dot.
I'm still not 100% convinced on how we would do that. I think once we have you prepared something for today, Michael? The key stuff.
Yes.
Okay, because then the discussion is also, it's also depending on how this goes. At the moment, it's specified as we always specify everything. So that means if you have a NIST directive and you have a coordinates input where you require to have coordinates, for example, here, then you have to specify it as a type, just because it's less ambiguous in some cases where you, for example, have a I think I have defined a few cases where it could be ambiguous if you do not define the bracket.
But I mean but the aliasing isn't needed, right? We don't use that for single field references.
Yeah,
like
but
you
it's an
don't-
input.
Yeah, but I mean, what's the difference here?
So
Why-
this is the input object, so that would be location input. That's
Yeah.
until here, and this is the spread of the output type, which we basically we drill into coordinates and then we map it.
Well, yeah, no, I get the semantics. I'm just wondering why we need to explicitly name the fields if we can derive them from
Well, in this
the
case,
output
in this
field.
case, in this case, we do not really know it anyway, right? Because this, I mean, we could technically get it, I guess.
I mean, it's always nested under coordinates the way it's specified here, right?
Yeah. Well, the reason why we specified is just to be more explicit about it, because it's always easier to remove stuff rather than add stuff in the, I would say, explicitness. This makes it really clear what this is, because this shape always matches the shape of the input, which is quite nice. So you don't have to think, more or less. You know that this is the input and it will always map the same thing. So we could actually remove all the output types here and then just add the output values here. And then we can just move it into the input and it would actually map the shape. That's one reason for being explicit. It's up for discussion if we should remove it, but I think the rules here could get a bit messy. Just a feeling. I'm not sure if it will actually get.
Yeah, I guess
messy.
this is just this. It just happens to line up convention wise, right? Maybe to make it more clear in the spec, maybe if the last input, the field location input dot coordinates, maybe if we just make that in the spec as an example, if you make that location input dot positions, right? So then the syntax here, then it's starting the brackets positions is coordinates dot lat and coordinates dot long, right? Is that
Yeah, I mean,
we want to
yeah.
be just happens to line up that we use the same field names for the input and the output.
Yeah, I mean,
Yeah.
you always need a label if you need to rename it. That makes sense, but for
If we
cases
didn't
where,
have
I mean,
it-
I think it's very common for sort of the output type and the input type to share the same fields, and then it becomes very superfluous to sort of list every field twice.
Yep.
If it's a list.
Yeah, I agree. At the moment, I said it's specified just because it's less ambiguous this way. We can discuss this, but then we have to have like really strict rules of doing it. I'm not sure, but if the benefit is worth the difficulty in specification.
I don't see the ambiguity, but maybe that's something maybe I need to read up on this. But I think it's similar to sort of the rules for GraphQL selection sets, where by default, like the response name is the field name, but you can override it with an alias. In this case,
Yeah.
So
but by default, the input field name is the same as the output field name, but you can rename it.
So in this case, you would just say here coordinates
Yeah,
instead, and no map. If in this case, I think it's okay because we are renaming. But in the case coordinates matches, you would just say coordinates.
yeah, but here you're not renaming either. You're not renaming coordinates. You're renaming what's nested under coordinates.
Yes.
But you're not like I think you could remove the coordinates colon
Because of this.
because of that. Yeah.
Yeah,
No,
but
I'm not-
what if
I'm-
you? Not sure.
So-
Could
so
you?
the
What if
field-
it's three? Yeah. I know.
So the fields are the same, but the types are different, right? So it's
Yeah.
and that's maybe part of the confusion.
You're
Uh,
mapping essentially the nested types, right?
Yeah, but that's a separate semantic check.
Yeah, I would say in most cases you probably have the match, right? When we have a look at, for example, do we have a good example in here?
We have to find out if there's ambiguity. If there's ambiguity in some cases, then
There is when you have this could, for example, be a selection, but it could also be a selection set. So you need to look at the type to actually know what this means. You know, it could be an object, but it doesn't have to be an object. It could also just be a string. It could be just the ID, or it could be an object.
Yeah. I mean, you always need to interpret it in the context of, in this case, user, right?
Yeah.
That's how you get to the type, and then you match it up with the argument. That's the check. But I don't see any ambiguity in.
Well, if you just look at this.
Oh yeah, but you need information about the rest of the schema to be able to interpret it. I think that's a given. We have that for key as well.
Yeah, I think I have a few examples of ambiguity, but I think it's more or less only if you look at this, because with the type, it usually becomes very clear what it means.
Yeah,
maybe
but I also think the interpretation does not depend on the ID type here. Like the interpretation depends on the user type, on the type of the ID field in user. That's what decides what field ID refers to. And then as a next step, it needs to be compatible with the argument type. But the source of the type of ID is user.
I see. Yeah.
So
Yeah, something that
question. So in this example, shouldn't that be user ID : ID explicitly? Or?
No, because it's not an object. It's just a value.
Like Pascal is here using still the is stuff. Like
Yeah.
I worked a bit on the lookup stuff to eliminate is as a proposal.
Yeah.
And if it depends on what we are using, like what path we are going forward with.
I would say the same thing. We may have, I mean, we prototype with a few things. So we may kick out if I mean, the proposal basically would get rid of is completely.
But
So
we still need that syntax, including sort of the naked syntax here for require. Like we still need
I also reworked require. Let's have
we also kicked out the is in require. But anyway, let's revisit that. I mean, I will push this anyway, so you can you can also comment it on the pull request after the meeting, and then we can see where we want to.
That's fine. Yeah, I think that this first name column first name is another example of the same.
Yeah. At the moment, you see that it's specifically defined as this is an example. This is a counterexample. So the specification at the moment explicitly does not allow for the shorthanded syntax. So we'll see where this goes, and then we can remove this or specify it in this.
But there are two different issues. Like because the counterexample doesn't have the braces, and I think we still need the braces to disambiguate the single value versus input type.
Right. You just about the names. Right. Yeah. Okay. Fair enough. Let's comment it on the pull request, and then we can explore this. So I think these are all the things that changed from last time. So we now have the pipe on selected value instead of the path. We have to prototype a bit if this works, but this actually looks quite good. Now, one thing which I started adding now is the validation bits. We will need quite a few rules actually. I've added this schema as an example, and based on this schema, I now start writing the validation rules. We need quite a few. So we need the path, the field selection, which is basically, I will also write this. It's the same thing as the field selection validation rule in GraphQL, which means that each segment defines a field which is actually available in this context. Then we have the terminal field selections, which means that if you have a scalar, there's no more path segments. And if there is an object type, an interface, or a union, there has to be more path segments. Then we have the type reference is possible. So basically, these were the outputs, the output rules of the GraphQL spec, which are a bit adapted to the path. And now we have the fragment rules, which is the type reference is possible instead of the fragment is possible, which basically goes into that you only specify the type which is possible in this location. And then there's the input, which are actually, I think, 4, which I still have to add. This is non-repeatable inputs. It's non-repeatable input fields. It's that the values have to match and all these kind of things, which now are basically also the same thing from a bit adapted from the graphical specification, because it's the same thing essentially. It's graphical. It's just a different syntax for it. So that's the state. Any questions so far?
No, I mean, thanks for writing things up in the spec format. I think we probably need some time to review it. But it's yeah, I think this is a great starting point.
Yeah, I mean, there will be a lot of these things to review as soon as we start with the composition, because then we only have these rules.
Yeah,
We have written for Fusion, we have written like, I don't know, already plenty. So. And it all looked like this. Okay, that's it. I will push this. Please have a look at it. I will push it in this state, so there's still 3 or 4 rules missing. I will push this, have a look at it. This is also what I will show in the public one next week, and then we can make a decision on syntax. I've also seen your comment today in Slack, Martin.
I think the public one is still 2 weeks away, I think. So we still have 1 week among each other.
That's fine. All right, that's good. So I personally prefer this one. But I'm also up for discussions here, so we can.
But no, I mean, I like this. I think that it was more. I thought it was an interesting example of sort of similar functionality.
Definitely, yeah. I think what we try to do here is we solve a very as soon in the validation rules. It's very apparent what we do, because we need all the output ones, we need the input ones, and we need the fragment ones. So we mash everything together in this path selection, field selection syntax, which actually shows that the problem that we solve of mapping outputs to input fields. So let's see. Yeah, I think I'm good.
Okay, then let me take over, because like this is actually one thing we discussed last week. We came up with shouldn't we just have maybe get rid of is, and then have just a single lookup, and that has the selection syntax on there. And this would kind of look like more like this, where we have now the finders. I think I like the syntax quite a lot, because now it's like we are mapping from here. And then you also always need the braces, because what we are mapping here is basically, basically these guys to the arguments. If you have 2 arguments, you would have then like also that in the object defined. But you have a very clear schema now. And this
But then you need double braces in case of an input object.
Yes, I have that somewhere here. Do we have it somewhere? Yeah, here it's different. Yes, you need, if you have an input object. Okay, I can add that as an example, so we can have a look at it. We could also leave them away and say, okay, if there is not an object, if it's just the arguments, we could just leave the braces away. It's a bit more complexity. But then you just have a list of these arguments, right?
It's also the double braces wouldn't be double braces. It would be a nested object. So when you have an input object, let's say that ID would be an input object, then you would have ID and then the object.
Yeah, it would be kind of. Let's go quickly here.
You're right, because it's always named in the syntax.
Yeah.
Yes.
So if we had that here, that were an object, and that's its object. In this case, we would first say object, and then we would do the name mapping.
Exactly.
Yeah.
Does it make sense?
Yeah.
Okay. So what this, from a schema perspective, this is now very clean because we have here the lookup. And as I described this, each of the lookups need to match a key set, if you want to, if you will. Like in this case, for instance, this lookup matches this key. That's a bit double bookkeeping. I talked about that with Benji today, but he also saw the value of it. So you have, like, if you have a schema, if you have that in a commit, you very clearly see the impact that you have on the schema if something changes in there. And to derive, technically, you could derive the key from the field, but it's not so clear if you review such a change that this has an impact on the key itself, right? Okay, so what this makes is essentially we have now one lookup here. I introduced one more directive into the mix, and that's patch. I know we haven't settled on the name, so we had a couple of them. We can settle on that at a later point, but like we will have to have this functionality of these patch lookups.
So Michael, before we go to the patch, how would that actually, can you scroll up a little, like one-off? How that,
Yeah.
did you split it?
Oh, yeah,
split it up into-
Sorry, I didn't go into the syntax specifically. Like if we have here a lookup, this lookup for like here a person finder, for instance, which is a one-off, would work that we have here key 1 defined, which matches this key, and then key 2 defined, which matches this key, and it's basically depending.
That's I mean, just detail, but there should be actually one wrapper around it where you specify finder on each side.
Oh yeah.
So there has to be the argument name.
You're
Well,
right.
so with the one-offs, I'm thinking it might be actually easier to think about the at lookup as one-to-one match with the key. So if you have a one-off, maybe it's easier to have a separate lookup directive, so it's a repeatable. So you have a lookup for one-off and lookup for another part of one-off. I'm not sure.
So the one thing that we have to I guess come up with is that we discussed today about having it repeatable or not. We settled on we do not need it repeatable, but the thing is that the one-off thing is actually when it's nested, it could be that it's 2 different keys. You know, when you nest it and you have an abstract selection, it could be that you have one key which selects the movie and one key which selects the book. So I believe that we actually need the pipes.
Yeah.
But we also
because they can be at any level.
Yeah, and we also need it repeatable because each of them defines one key.
If that's the correspondence we go with.
Because otherwise you would have the ambiguity of, is it now 2 keys or is it 1 key?
Like the thing is, if we have 2 lookups, is these 2 lookups would only affect the top level thingy. But the moment you go deeper, you anyway have to use the pipes, and that is kind of inconsistent. And that's why we, in the proposal, just removed it. In the first version of this that I wrote, I actually had 2 lookups, but just with a couple of examples, it falls apart. And that's
one-off is like a 4 level deep and then puts. Yeah.
I'm not sure if this corresponds to these keys though, because if you have it like this, specified, I think it's one key.
Yeah, that's one thing I want to point out because there's two
Yeah.
examples I can think of. So if we maybe
Yeah,
just look at
that's
this in
why-
real time.
Yeah,
There's-
that's why I initially defined it differently, Pascal. And you're right. Actually,
So-
it would need to be like this, right?
Yeah, now you would use the pipe syntax to define two keys. Now the question is, what's easier? Is it better to have it repeatable, or this? That's up for discussion, I guess.
So
Because
Yeah,
one
but-
change. What if line 130? I think this will answer both
Yeah.
questions. So if you go back to the change, just line 130, untype person, you define the key. So
Yeah.
the first key, make that ID and name. And then just, I don't know, for some, like this is technically possible. I don't think it's valid, or maybe it's a third
Yeah.
field, like foo, right, is the key. Like
Yeah,
um,
doesn't matter.
Well, no, it's actually does matter because if you have ID and name, we'll generally prefer just the name if they're overlapping, right? Because
yeah.
and
This
so,
actually
like,
this
foo,
doesn't
yes,
matter in
foo,
comparison.
whatever,
So
yeah. ID and
Yeah,
foo, yeah. Yeah.
Okay. And then we would have here now foo
is foo, yeah.
matches foo, right?
Okay, so the pipe is dividing unique keys. And so I guess the
Only
question is that
it would only be like this on the first level.
Yeah.
That's the confusion.
And I think, I mean, this syntax quickly gets confusing if you really
I mean that is opposed to just let's put the other again.
yeah.
It's opposed to this one, right? We could do that. I mean,
The nice
had
thing is that
this-
it matches it. I agree with Derek there. It matches the amount of keys that you
keys.
have specified. On
I mean,
the-
we
on the
decided
type.
we discussed it when the first iteration on this proposal was actually to have this repeatable, but we wrote that then
Yeah.
to this pipe syntax.
But the problem with that is that if you have a lot of branching, then you have a lot of duplication. So then you will have a
Yeah.
lookup that like it will be like not infinite, but like a lot.
Yeah, but we could like just to follow the argument that we had there. It could mean that you have this has to match like one lookup directive has to exactly match one key directive.
I wonder if that isn't too restrictive.
Just one thought to make it very
So-
easy to read.
So
Also in
one
this
thing that I
case-
would like to stress out that in vast majority of cases, we are looking at the simple situations when folks are using simple keys, whether it's one or multiple IDs, right? The edge cases are when you know we have the devil in the details kind of thing that's actually gets confusing with those lists and abstract types and all that crap, right? But I think we should optimize for the simple cases for folks because that's going to be vast majority of use cases, and in my opinion, is actually less cognitive load to say that you have a lookup matches to your key. But that would be my reasoning.
Okay, one thing to notice is that it will also won't work with 1.0. So then you have this like conflicting state when you have, you know, ID and foo, and then just the name, and then you cannot really define it on the input, right? So then you have to like have one off, but it would be like key 1, key 2, and then key 1 will be another input, and key 2 will be another input to just match the key fields, right?
Yeah. And we need the
Uh,
pipe for other cases, like the type cases. So
Yeah, that's
we'll have
where
that
I-
in the syntax anyway.
Yeah, that's why I asked about I want to ask about the branching that you mentioned before, Camille. What do you mean by branching? Because
By
I think the
branch-
pipe could solve this issue. Because any key that you would define as one key, you could define in the lookup as one lookup. It would be possible, I guess.
What I mean is like if you have a union or an interface, then depending on the fragment that you define, you can have different fields, right? So then
Yes.
you have a split, and that's what I mean by branching.
Yeah, but you could do that with the syntax in the lookup, because it's the same stuff that we used on the
Not really. The structure will be different, so you need to have a pipe. No?
Yeah, but I'm not saying that the pipe is wrong. We have the pipe anyway. I'm just saying
Yeah.
that we discussed the pipe on the root level to make it easier to reason about that a lookup matches the key. So we do need the pipe, but we might get around having the pipe on the first level if we just make it repeatable, because it could be easier for people to understand if we just make it repeatable. We do need the pipe anyway. For for example, nested one-offs, then you already need it.
Yeah. I mean, I guess we need to see more examples and sort of see them side by side, but I'm not convinced the correspondence between key and lookup is worth the extra complexity in the map syntax. Because with is,
So
you have the implicit connection. So for instance, you don't need the finder
there's
name there.
There's one reason why we explored this syntax, because the is syntax has ambiguity. When you have more than one argument, you do not know which is directive course. If you have two arguments with different keys, then you do not know how these keys relate. For example, if you have I don't know, instead of a person finder input, we would now have just a field which accepts an ID or a name, and both are nullable.
Yeah.
It's not best practice, but let's say both are nullable. You could pass in a string to the ID field, then you would fetch by ID. You could pass in a string to the name field, you could fetch by name. That means that you basically have a key set of ID and a key set of name. Now, how do you express this with is? You would say is on the first argument and is on the second argument. But
Wait,
what
but
if the key?
What are the two arguments here?
Michael, can you type quickly? Just person with two arguments. Just do person and then do name and ID.
Sorry, person, name.
Name string, ID string. Doesn't matter, or ID if you want.
And they're both nullable.
Yeah, let's just say so.
That
what
seems
happens?
like, I mean, that seems like a bad practice. I mean, that's why we have one-off.
Yeah, but you will see that.
But like there is a proposal, like one-off also defined. It's one of the side proposals that we didn't put in the initial proposal, but they were one-off arguments.
Mm.
And also one-off doesn't technically exist
Yeah.
yet also. So this pattern does very much exist out there in GraphQL. Like it's person, the field name would be person by ID or name, like called like that, right? And then you have two nullable arguments, like
And now when you specify is on name and is on the ID, then you have, what do you have? Do you have one key, name and is, or do you have two keys, or do you have three keys? Because you do not know how Michael, can you just add the
So what you have actually is you would need to differentiate with pipe, right?
No, I'm talking about the old syntax with the is. The reason why map why map is superior, lookup map is superior. Because if you just do it now here with is, you do not know how the directives relate. Is it one key or is it two keys?
But I don't think that's any different from having a map with a pipe in it. Like is name and is ID, I think, is similar to having a map with name pipe ID.
But you're able to now with the map, you're able to make it name and ID one key.
The argument is the following.
But that's only if we think there needs to be a one-to-one correspondence between a lookup directive and a key directive. And I wonder if that's tenable.
You can, with the is, you cannot express that both arguments are from the same key. So the key ID foo that we have on line 136
how would you express this key if you would have two parameters, ID and foo?
The problem is, how do you explain that this part is of a different key set than this part? With this, you can just say this is semantically this thing.
Yep.
Mhm.
But with
So
map,
just-
we can, yeah. But
Just
with
change
map,
ID right here to foo, and I think that explains it very well. So, wait,
what?
right above, change that to
That-
foo.
Is to foo?
Yeah,
Sorry, or it's ID and
third
foo, not-
argument,
sorry, name and
yeah.
foo. So change the first argument to ID as well.
This one
Yes,
to
So
ID?
this is a lookup for just one key, right? Just a lookup
Yes.
for one key.
and
Doing
if you
this
now
with
express,
is kind of difficult.
yeah, exactly. That's it. Can you write the is directives quickly, because then I think then it becomes really clear what the difference is.
This is
This is like ID.
Yep.
That maps to the foo.
foo.
But now we have two is directives. They're technically describing the same singular key set. But there's two is directives.
Yeah, I mean, I guess I've never thought about a direct correspondence between lookup and key. In my mind, what lookup signals is that if you pass in certain fields, the output, they will match up with certain fields in the output object. And then as a second step, like the fields you get back from a lookup decide sort of which key you can apply.
I guess I was going to say no. I've always thought of it as exactly one-to-one mapping. Like you are the fields you specify on the output are on the input. The things that should be on the left side for the input should be a key set. Like that's the expectation, right? Like we need a key set. Like that's the whole point, right? Is that like we're mapping the inputs to the key set of the return type.
Yeah, the way I described it also in the spec is exactly like that, that there's a correspondence between the finders and the keys.
Well, there
And-
is a correspondence, but it's sort of it's in two stages. Like you don't necessarily need a correspondence at the sort of the syntactic level. You don't need a correspondence between a lookup directive and a key directive. What the lookup directive tells you is what kind of return value to expect for certain input values. So it tells you, like in cases like this where like both ID and foo are marked as nullable. It's sort of a weird situation, but what this tells you is that if someone doesn't pass in, for instance, foo, you can only rely on ID, even though there's no key with just ID here. But it still tells you something about the behavior of this lookup. And then as a second stage, you can sort of derive that if someone doesn't pass in foo, you don't have a valid key. But that's a second stage. You can expect there to always be a one-to-one correspondence because the arguments to the field don't give you that guarantee.
Yeah, I would say
Correct.
but you do not know if you can, if we do, can we add one field more in there with the name?
Yeah. It's by
Because
person by
then-
ID, foo, or name.
Yeah, and in that case, it's even valid for someone to pass in like 3 arguments, or 2 or 1.
Yeah,
That's-
but in this case, it could also be like, and this is a bit the contract that needs to be expressed here in the, and you can much better express it with the finder now, with the lookup, because now you can express that actually this pair has to be passed in, or this has to be passed in.
Yeah, but I guess what I'm saying is that part of the contract is already specified in the key. That's sort of one part of the double bookkeeping. The other part is the behavior of the lookup method.
I 100%
but
agree. Go ahead. Sorry.
Okay, no, go ahead.
No. I didn't want to
Yeah.
interrupt you. Sorry.
Well, I mean, I just wanted to say that the lookup, like the map, like if you specify in the map that, for instance, ID and foo always need to be specified together, that doesn't change the fact that you can still like have a query where you pass in just ID or just foo. So you end up in a situation where you get sort of a false sense of security.
Why do you
Yeah,
get
So
false sense of
your
security?
question is, should this pass composition, and because that technically at runtime someone could just pass ID, and then like does the implementation check that at runtime, or is that
Yeah.
just like an
Yeah.
error, or is it like
exactly.
Exactly. Yeah. So either so what you're over specifying if you put it in the lookup, because you're saying that the semantics of this root field are something that you can't guarantee.
Yeah, but it's also
there is one case where it doesn't work, and this is when you have for the keys you actually have resolvers. If you have too much overlap over the fields, then it doesn't work. For example, let's say we now have a field which is person by ID, or foo, which actually can resolve two different keys. It can resolve a person where you have the ID and the foo, and it can resolve name. Now, let's say that we would have a key on person which is also ID, and we would
What
have
do you
a
wanna have?
person. Just add a third key on person, which is just the field ID. Now you have
So, by the
overlapping.
way,
Now you have overlapping keys, and at this point, from without having the annotation, you could get just do ID, With this, you now have the problem that you could pass in just the ID into the person by ID or foo field, but it actually expects a different key set because it would actually expect ID and foo.
But the thing is, like, even right now in Federation, there's these entities, right? And you expect to pass whatever, but the resolver, like, it could be technically like type safe there, like when we speak like TypeScript and stuff, but it could, like, it may not, like you expect a set of like an object that, yeah, it should exist, but the only thing that actually makes sure that, yeah, the correct values are passed is the gateway, right? So if the gateway falls apart, then it kind of is the same story as you would have the product by ID or foo or whatever, right? So then
but
the
you have
security
sorry.
or like the key, like the check will eventually have to be on the subgraph anyway, on the resolver. You know
Yes,
what I
but
mean?
you
Like
have
even if you have like
entity
input with
resolvers.
one off.
You have entity resolvers, which are
Yeah, but
specifically designed to handle multiple keys.
yes, but what I mean here is that the ID and foo or name or ID, this is just a contract that is like imaginatory, I would say, because yeah, there's like GraphQL validation, but with the one off and piping and all of that, like there is no like I don't know. For me, like
Yeah.
like
I
you
agree with you,
eventually have to have a validation at resolver level if everything was like correct, right? Anyway,
yeah,
like you
ignoring
have
if we didn't have a lookup and we had just keys, right? Like, and you had this resolver and you had keys that was ID and foo and name, and you had this resolver that could pass ID or foo or name, all of them nullable. Like, it's implicit, like if that is actually working somehow on your resolver side, like you would have some check to enforce that already. So yeah, well, technically we could get a runtime error if you're not doing that. That's like not our problem, right? It's like it's a thing like it's like, well, you didn't implement your entity resolver correctly. And is that something we need to handle with composition?
No,
Well,
like the
it's-
implementation side, it's more a schema check that. Let me show you one more thing before we get stuck on this, because like why I also find at the moment the having that in the lookup very nice is because we can make it very nicely work always also with requires, right? In this case, we also like it would line up with you have one directive for require, one directive for lookup, and one directive for patch, and that would very nicely line up, right? And that's actually also mapped. As I said, it's not fully typed out. As
So
opposed to
I
what
thought
we
that
had
we
before.
wanna- For the require, I thought we want to do it on the arguments, because I think it actually is nice pattern.
We had
to
it
have.
on.
Yeah.
We had it on the argument. This is just because we discussed this, so I wrote it up so we can discuss in which
Fair enough.
way we want to go, right?
Yeah.
There's not that we. This proposal just comes out of the discussion that we did last week, and so I just wrote it up so we can get a feeling if that looks right to us, or if we want to keep it like we had it before, right? What we had before was, by the way, that we had this kind. We would have this kind of thingy here. In this case, this would essentially work out.
Yeah. I like that because it makes it very clear what's happening at runtime. Like we're passing in a value to a particular argument. And it marks the arguments that receive a value from.
Yes, that is the nice thing, and that's also with the is. I mean, this is like this was my thought when we put that in Fusion. Like we have it like this, right? It's like the injection for this argument that you define here, and this makes it very, very clear.
So just a clarification, so on the 222 line, it should be dimension dot weight. So require dimension dot weight, or is that
yes. I just copy paste mistake, right? It would
And
like in the original proposal. This is this guy here.
I think it's dimension dot size dot weight, right? Because the input object has a different structure, I think. Or where does the dot?
No. The dimension is on product actually here.
Yeah, but in any case, so we want to have the basically on the argument there it says that it's actually coming from another place. This is mapping to specifically to a single argument. But that's
maybe
and I do
just
like
to
that.
Good. Maybe to take a step back, going back to the previous discussion, I think one of the questions we need to answer is sort of how we expect like there are currently no lookup methods that people are using. Like people rely on the existing underscore entities behavior for federation. So we also have an opportunity to educate people. And I think the kind of checks we can perform at composition time will help there. So although we can discuss edge cases where, for instance, there's ambiguity because like all the arguments are nullable, it might actually be important to flag those and like tell people explicitly that this behavior is ambiguous and they might want to replace it with something more explicit. So I think that might be the right angle to sort of look at the way the lookup and the key match up. It's to see how we can provide sort of useful information to people so they can improve their schema design.
Yeah, in any case, like the mass data transportation that people do with key is something that needs a different mechanism if we want transient data, right? So we could also go stricter with lookup. What we kind of just do is a bit see where the constraints are here. We could put in constraints and say this is how lookup works, and we don't cover this case. Like if you want to do that, that doesn't work this way. You have to specify this with a one-off input type. Could also be a guideline. This is something that comes into the spec, and this is exactly for this use case, right? So we could also say, this is where we say, don't do that, do this.
Yeah, I agree. I think if we be more restrictive, that makes everyone's job easier, both for teaching, learning, understanding the spec, everything. I just want to clarify, I wholly expect that we are going to have to retroactively add at lookup to existing APIs. So like the Shopify API exists there today. Like I want to be able to say, okay, your API exists, but I could just simply, post to Shopify even doing this. I can just add at lookup to the schema and then like give that to a composition process, and it'll just magically work. Like the router and gateway could figure out, oh yeah, even though the original schema doesn't have lookup, if I properly annotate at lookup with all the correct information, it can still work and add that Shopify graph as a valid subgraph. But again, Shopify might not be following like the one of patterns or like have all these stuff. It's just a legacy GraphQL schema that has all these things. So I think we should be able to fully support that use case. Now, I don't know if Shopify that it also seems like a bad pattern for their API if they just like say, here's a bunch of nullable arguments and you pass one and we just figure it out. It's like, I want to support the adding lookup retroactively, but also I agree that like, maybe this is just a limitation of like, that's a bad pattern. We can't figure it out and restrict that. And we force people to make updates later, or we revisit this conversation if it comes up again with enough people requesting to support this.
Well, I think we can support it while still flagging it. So if you look at like the like line 132 here, like we have all the information we need to sort of infer what the behavior of that field is. And based on that, we know there are ambiguous cases, but as long as people guarantee at runtime that those never happen, we can still sort of know which fields specify which keys.
Okay. So then we could leave it up to producers, or, again, like, hey, warning, not composition error, but a warning. Like this might cause runtime errors. You might want to double check that your implementation really does do runtime checks.
Yeah.
I mean that like in a proper implementation, you always have that, right? You always write. You don't trust the composition. You would always write guards in your resolvers that make sure that what is passed in is kind of validated.
But the question is, what are those safeguards? Like, just looking at this as a normal GraphQL field, if you didn't know anything about the lookup semantics, I mean, it's just 3 optional arguments. It only when you declare it as a lookup and we sort of expect those semantics, can you start reasoning about which inputs are needed to look up an object and check for those. But that might be implementation specific. Like it might be the case that even though strictly taken, the entity, for instance, requires ID and foo. Foo might actually be a constant, for instance. So maybe you only need ID as an input argument, and you can there's a default value for foo or something. I mean, there are weird edge cases here that you might need to consider.
There's also I talked about. Sorry, who wanted to talk?
Yeah, but it's just me. I want to say this since we talked about checking the resolver. If the resolver has to check, then it's too late because the gateway has already decided how to route the traffic through. So if the check happens in the resolver, then we have already failed.
That is not for that. Yeah, right. What my comment was just, you always have to have like boundaries in your resolvers.
It's about the stuff before. The boundaries in the resolvers are great. You should have them 100%. But if we cannot
route the traffic to the right resolver in the first place, then we already lost if we hit this if, which checks that two of the variables are set, two of the arguments are set. If we hit this if and it's not the intended way to route the traffic, then it's too late.
Yeah.
Then we have runtime error, which we could have
Yeah.
evaluated in the composition that this will never happen if we would have the correct key sets, right?
But again, it's a runtime error. We wouldn't compose a graph that would send a bad query to the subgraph, right? Technically. So like we created a valid supergraph in terms of what we could know possibly.
Yes,
right? Like
it's valid graphical and it generates valid graphical. I agree, but it's a wrong domain model. It's a wrong idea behind it to send only one, because you would know if this example that we have here is not good, obviously, because it's not a real use case. But I think for me it shows that there's a possibility that there are real use cases. We can just not think of it, like with the pipes, where we go deeper into the tree and we suddenly realize, well, now we have a problem. So I'm pretty sure that there's probably key sets as soon as we start getting into more complex keys, where this really, you want to use the specific key mappings to route traffic on your subgraph, but could be wrong.
Yeah. There's one other case I talked with Benji today about, and this goes exactly into pulling in external APIs by annotation, right? You could write, and that's what we actually did in Fusion. You write an extension document where you just extend the existing fields with some annotations, and then the composition knows semantics, right? And then gets you pulled in. Where this still falls apart is if you have hierarchical fetches where you can get a thing, like you need to fetch, for instance, the organization from GitHub first, and then you can get the repository. And this kind of is the composite key. Like if you don't look at external schemas, then this is not a problem. We can always say you have to design it this way, that you need to introduce the repository here. And then you also have to, for instance, pass in the organization to get that. And actually, this is how it is in the GitHub API, right? And if you have such a technical field to fetch that, no problem. But if you have it hierarchically organized in your graph, then this is at the moment not what we can do. Right?
That's a
This
good
is
point.
also
Yeah.
one limitation. And we can say we don't want to solve this in this first thing. It's also okay, but we should have these kinds in mind and maybe think about it at least.
Yeah, I'm wondering if two lookup directives would give us enough information here. Like if we annotated the organization lookup here in query, and we also annotated the repository.
I thought about something like this, and then like if you have it stacked, you need to analyze the schema a bit more. Then you know, okay, if I come through this lookup to this object, it's basically a composite key. And if I get to another way to this, it's another composite key. Like, for instance, if you have another way to repository, right? Through another object, this could work out.
like users
Right.
in the repository.
Yeah.
Something.
And now, because when we analyze the schema, we find that that you get from organization with this lookup, you get to this type, but there's another lookup on there. You know, it's kind of a hierarchical lookup, and this then aligns with a key, maybe on repository or whatever. And then you can figure it out from there. This, by the way, is more difficult when we go for such a lookup than with the is directive.
Yeah.
As a counter.
I would
Yeah,
personally.
because
Yeah.
you can build up the key from different levels.
Yeah.
Yeah, I wouldn't go multiple levels because that's gonna be overcomplicating things, and I don't think we want to tackle this in the first draft or whatever spec version. Maybe we can expand on later. I would keep the lookups at the root level queries for now to
Well,
keep this.
we need lookups at nested levels anyway for people who use sort of namespacing patterns. So we do need to support lookup at other levels.
Also,
Yeah, at
think
other
about the-
levels, we
think
already
about- think about the node pattern. If you have, as soon as you have node, you can actually, if you have a lookup on a subtype, it's going to be so nice if you have just the ID of the node and then some parameter of the subtype, and you can just use the node field to fetch stuff with the combination of two keys, the ID of a node or an entity and some parameter of a subfield. So it's actually, it would be really nice to have nested lookups.
there's like at the moment what we explicitly called out in both specification versions, the one that we have here and the one that I wrote before, is that you can have nested lookups. Yeah, here.
Yeah.
Like this is allowed, but we called explicitly out to not allow any arguments.
Yeah.
To keep it simple. But like this is for namespacing. But what we have down here now with the GitHub example, this guy here is actually to allow a hierarchical key.
Yeah. I mean, I think we have all the information we need to sort of infer what information we can have at the repository level, right? With the two lookups.
The only question is what do you do when you do not want to be something a lookup from one path?
And
a combination of key and value that you do not want to have as a key set. That
Well,
would
but lookup sort of gives you a guarantee. Like the semantics here are that whatever organization is returned will have the same name as the input value. And same for the repository. So that's the only guarantee that a lookup gives you. And then whether you can sort of infer a key from that, or whether you have enough information to construct a key, that's a second stage. That's what happens after you.
Yeah, what this guarantees you is that you get that. What this guarantees you is that if you have organization, then this is a lookup field where you can pass a name, and it gives you back a repository that matches this name or null. That is essentially the guarantee of the lookup here.
Yeah.
It comes with more exploration cost in the composition, because you have to build them up. Like you have to build up hierarchical lookups. You have to traverse a bit more.
But also the hierarchical lookups, right? The problem is, or technically when you're inside of the organization type, so the repository can technically depend on some other fields that are local to that organization type. I've seen that resolvers often do that.
Yeah.
Yeah.
That not necessarily be called out, and that actually gets very confusing very fast if you do that. So that's why if they're not like explicit on the lookup part itself of the arguments, it gets messy.
Right. Yeah, I'm just, so if we want to go after, you can annotate an external schema. You will get into these use cases.
Yeah.
If we say we limit, this is a valid point we can also make. We can say for version 1, we limit us to non-hierarchical lookups, because we can always add them later.
Well, as long as we explore the design space, like I'm
Yes,
fine with
yes,
saying
exactly.
we don't include them in V1, but we need to take them into account when we make
Yes,
the kinds of decisions we've
definitely.
been discussing today. Yeah.
Exactly. That's why I brought them up. We have to look at them. We have to recognize they exist, and we have to explore if it's maybe also a quick win. Like, is it even so difficult to do it? But yeah, and then we can make a decision to take them in or take them out.
Yeah. Great. Yeah, that's a lot to think about again. I think we're already over time. I'm fine moving my question to next week. It's already on the agenda for next week, so we can just keep it there.
No worries. But this was super productive.
Yeah, definitely.
So I just before we go out, so where is the sentiment? Should we go with is that more the one that we want, or is this something we want to explore?
I think that also depends on the decision we make for require, and especially for require, I feel even stronger that it's a lot clearer if it's on the argument.
Yeah.
And that to me signals.
But the one arm, the read, so for the require, I definitely like it on the arguments. I think it actually simplifies things. But for the lookup, I feel strongly that that should be part of the lookup, simply because everything else that we actually describe in our schemas using those directives, we use a single directive to describe a single concept. If using a lookup and is means that you have to apply two different directives to apply a single thing, and that to me seems backwards.
I mean, you only need the is if the name doesn't match the output name.
But
Exactly.
still, it's two things.
So this is a little misleading in that respect. Like, we're sort of explicitly including is everywhere here, but in most cases, you just need the lookup.
It just brings semantical context. But if you have this guy here, for instance, then and this is a one-to-one match, you just need this.
Like, without the map, right? Without the grayed out.
Yeah.
Yeah.
Sorry, Copilot.
Yeah.
But you could, in the same
Right.
argument, be said on the lookup side of things versus it and is. So
Well, I think with lookup, it's a little less clear what you can leave out, right? Because if we do specify the map in lookup, it gets weird when you map certain arguments but not others, I think.
Yeah, also I like the synergy. Like, if we decide on one, I like to have a synergy between them, also because of these specialities that you would introduce here. And if we can have one selection pass syntax and one concept how this works, I would prefer that. Because then it's one thing you teach them, and you can basically it's very simple. So is works essentially one-to-one, like require. It describes semantical equivalence essentially. Like we can think about it. We don't have to make a decision today, but like, these are the two options. We discussed them last week. You can all think about how you feel, and then we can make a decision which one we gonna write proper spec text now.
Sounds good.
Okay, awesome.
Thanks.
See you guys
Thanks for
next
the
week.
discussion.
Later.
Yep. See you next week.
Thank you.